Okay, this is our CST250 final project. This is group 12. And myself, Anthony Colwell III, also my other two partners, Matt Amos and Parker Jardine. Now for our team project setup, we had a skeleton code given to us, and we basically were able to split that up into three methods, or ASM files. First we have the bubble, which I did. Then we also have the insertion, which was done by Parker, and then the random sort, which was our wild card, and that was done by Matt. For the details of the sort, with the bubble sort is basically a left to right array. Checks for the first number to the next and then swaps them if the number is larger, and that continues and repeats until each of the numbers is less than the next. Basically it's in order, like from 1 to 10 going up that way. Insertion sort basically checks the first two numbers and then swaps them if the next number is larger. It checks the third number and after the second. If that is smaller, then it pushed to the front. This is repeated until each number is in ascending order. And lastly, a selection sort, and that picks the largest number out of the list, finds the lower number from the top, pops the number until the lowest number is on top, and continues the process until the stack is lowest to highest, top down. For my bubble sort, this is the setup. Basically, it's my declaration and setup for the bubble sort method, setting the array to a location to be processed from the declares, and the counter for the method. As you can see, I have a good comment there, so you can kind of follow each line and know what's going on. Also, I have the outer loop that basically checks the process for the sorting to be complete. I have the inner loop, which chooses a position, then checks it with the next position, and once they're all compared to the next position is less than the original position, then they are swapped. For this part right here, it's basically deciding what's going on. So I have the in sort. Basically, if there are only two objects to be sorted, then it just says, we're done. In loop continues the bubble sort process. The in sort goes past the loop, then it ends the process, and also the out loop, which it finds then that the sort is not done. Finishing it all up, I have the end of sort as a function that's made to finish the process and return the sorted array back to the main ASM function, where it can be displayed with the skeleton code that was provided. For the insertion sort, I'll go ahead and speak in behalf of my other two partners. This again was done by Parker, and the declaration of variables and their setup for this insertion sort, including the array addresses. A lot of commenting like you see previous, so definitely easy to follow. This is what he labeled as loop A, which is basically setup of the size of the array, runs through the array swapping values. Then as he labeled it, loop B, which takes in the information from loop A and runs it until the number is moved to correct position. And finishing up, we have end of sorting process after it has been checked and then sent back to the array to the main ASM file as said previous, so that the skeleton code can go ahead and display that to the UART. Lastly, we have the wild card, and that is again done by Matt, and I'll speak in his behalf as said previous. This is the selection sort that was chosen, and this is the setup that's taking in and putting out the selection sort information. For the parts of the algorithm, there are three main parts. The sort loop that keeps running until all values are sorted. The compare loop finds and swaps the smallest number to the beginning of the array and the smallest number. For a sort loop, loop simply checks if it's on the last element of the array. If it is, then we know that the array is sorted. Right here we have the compare loop, and this is where the sorting is done. We first start at the first unsorted element and compare against every other element. We find the smallest one and note its address in memory. Then we call a swap function to put the smallest element at the front of the array. Here's the swap, which is really simple, and we know the address of the front array and the address of the smallest value. We save the associated values in temporary variables and place them in appropriate locations. This right here is the results of chosen string being 720, 1080, 90, 180, and 1260, with showing the unordered string input. We see the output of bubble being 351, insertion being 231, wildcard being 313. And right here we're going to see the results ordered. This is if I was to go ahead and take the 190, 180, 720, 1080, and 1260, with the results of bubble being 138, insertion being 156, and wildcard being 298. So this right here is iterations it took for each sort method to either finish or fault. Didn't need to fault on either of those strings, so that was good. And this completes our presentation video for our final project, CST250. Thank you.